Welcome back to our coverage of the review exercises for Chapter 18, the normal approximation for probability histograms. This chapter has many exciting problems in it, and we have a couple more to look at today. We're going to start with item 12. Because although it's not odd, you can see in number 13 we repeat it. So let's go ahead and just do it. And then we'll do it again in the variation for 13. A box contains 10 tickets, 4 marked with a positive number and 6 with a negative number. All the numbers are between -10 and 10. 1,000 draws will be made at random with replacement from the box. You are asked to estimate the chance that the sum will be positive. Oh. So, can you do it on the basis of the information already given? Well, in all three cases, excuse me. I'm looking at so can we do it from the information given that estimate the chance that the sum will be positive? Oh, great. Okay. Can we do it on the basis of the information already given? No, we can't. Why not? Well, the box, for example, the box could have 4 tickets marked 1 and 6 marked -10, or 4 marked 3 and 6 marked -2. With those two different boxes, the chances would be really different. So imagine that you've got one box where you've got 4 tickets that are marked 1. Here's our ticket. But you have instead on the negative side, a -10 that's represented 6 times. Look at what I just discovered. Oops, sorry. And we've got 6 tickets that are -10. As you can see, this box is fairly extreme, and you could really create any box. You could have 4 marked 3, 6 marked -2, any way that you end up with 10 tickets in the box. And so, can we estimate the chance that the sum will be positive? No way. Now, in scenario B, can you do it if you are also told the average and the standard deviation of the numbers in the box, but are not told the numbers themselves? Now, this is a completely different situation because if we're told the average and the standard deviation, that gives us an idea of the expected value in the box. We know if we know the average of the box, then we can estimate the chance that the sum will be positive. Because we have the average and the standard deviation, we can use the normal approximation. That's why the normal approximation is so useful, because with just this summary information of the average and standard deviation, we can go ahead and compute this chance using the probability, the normal approximation. Oops. Now, let's repeat this idea. Let's look at these questions again. If we're asked to estimate the chance of getting 100 or more threes, can we estimate the chance of getting 100 or more threes on the information already given? No. You need to know how many threes there are in the box. And B, even if you're told the average and standard deviation in this case, then you can still not estimate the chance of getting 100 or more threes, because you would still need more information. 100 or more threes across how many trials? Oh, 1,000 draws, excuse me. No, I guess with B we could go ahead and use the normal approximation. But that's still, even if we use the normal approximation, we would still have problems estimating the chance of getting 100 or more threes out of 1,000 draws, because we're using the sum here, and we could get threes. We could get a sum of 3 lots of different ways. So neither of these are possible. Finally, a box contains 1,500 marbles. 600 were red and the others were blue, so 900 were blue. The following procedure was repeated many times. 100 draws were made at random with replacement from the box. The number of red marbles among the draws was counted. And remember, this procedure was repeated many times, this 100 draws. And we have our first 10 counts. You can see them listed here. Is anything fishy about these 10 counts? Whoa. Well, I think that it's fair to say that we should do some basic calculations here first. So what if we're counting the number of red marbles? It would be good to know the chance of getting a red marble overall. So what's the overall probability of red here? Ooh, what? There we go. Whew. Okay. So the chance of getting a red marble is 40%, but let's work it out. You can see there's 600 reds out of a total of 1,500 marbles. And this works out to a 0.4 or a 40% chance. Well, if there's a 40% chance of getting red just on any draw, and our first 10 counts are all below 40, that seems fishy because the expected number of reds is 40, right? You can see that. And the chance of getting 39 or fewer is about 50% or a little less. So if all 10 counts are below 40, this has an extremely small event probability. The probability of all of these numbers being under 40 for the first 10 counts just for your information, is 1/2 to the power of 10. As you can see, that would be an extraordinarily small probability. It's very unlikely. Yeah, the real issue here, the reason we know this is fishy is not because, say, let's say some numbers were repeated a few times. We can see 36 is in there a few times. That happens. Sometimes it just happens that a particular number would show up more than once, for example, in 10 out of 100 draws. But the real issue here is how these draws differ from the expected value. You should always be going back to, well, what is the expected value and the standard error for any particular chance problem. If we're asked something like this, many things go back to you're looking at the expected value or the difference between expected and observed values, which is what we're doing here. We know our expected chance of red is 40%, and so the expected value of red is 40, but these are all of the observed values being below 40. That's highly unusual. We would expect that the scores, the number of reds would be around the expected value, give or take a standard error. And thus they would be above and below 40, not just below 40. Now this concludes our coverage of problems from the normal approximation for probability histograms, chapter 18. Remember to go back to the core issues here that we've discussed: the expected value, observed values, standard error, and how you can use the probability histogram, when you can use it, and how. These are the important applied ideas from this chapter. Remember, still, for the most efficient way, do some statistics every day.